In this video, we are going to do half equations. So half equations, you may have met briefly at GCSE in electrolysis, but if not, don't worry. As long as you've got a basic understanding of them at the beginner level, that will just help you a little bit. You can download this resource for free if you go to chemistrytuition.net and the GCSE to A-level resources. You'll be able to download this free of charge. You just need to register. And then you've got a permanent copy to help you with your revision or if you want to refer to it during the course. So, first of all, what are half equations? Well, half equations are best explained by actually forming one. So let's have a look at the reaction between sodium and chlorine to form sodium chloride. So nice and easy. So first of all, we write the word equation, and now let's write the symbol equation. Balance that up, so we have two sodium atoms, a chlorine molecule forming two sodium chlorides. Okay, well let's have a think about what that sodium chloride actually looks like. And it can be thought of as being made up of two Na plus ions and two Cl minus ions. So let's have a think about what is actually happening to sodium in this reaction. Well, sodium, my two sodium atoms are becoming two sodium ions, and my chlorine molecule is becoming two chloride ions. But I can't just write those equations. They are now divided, but they aren't balanced in terms of charge because I have obviously lost electrons from going from Na to Na plus, and from going to Cl2 to Cl minus, I've gained electrons. So finally, I can add electrons into the equation. So for the sodium, it means I produce two electrons. And chlorine, of course, requires two electrons to become two chloride ions. And the final thing we have to do, the chlorine equation is fine how it is, but sodium can actually be cancelled a little bit because I have two here, here and here, so I can just cancel that down to have one sodium atom becoming a sodium ion and an electron. And chlorine remains the same, so I have a chlorine molecule, takes two electrons to become two chloride ions. Now, obviously, they are not, you can't just have that, you've got to have the electrons coming from somewhere, so that's why they're called half equations. If I combine these two back together, I will produce the full equation back up here, and we'll have a look at how we do that a bit later on. So let's have a look at some examples of forming half equations. The first one is Pb4 plus becoming Pb2 plus. So my charge has gone down and therefore my lead must have gained two electrons to become Pb2 plus. And that's my half equation. The next one is hydrogen becoming H plus. Now, first thing we need to spot is, of course, that is not balanced with respect to atoms because I've got two hydrogens here but only one hydrogen there. So first things first, I'm going to balance it with respect to atoms, and then I can think of balancing it with respect to charge as well. So H2 gives me 2H plus, and because I've got 2H plus, I need two electrons for that. Each hydrogen atom requires loses an electron to become H plus. And finally, we are going to look at Br minus becoming Br2. So again, first of all, I balance it with respect to atoms. So I need 2 Br minus to do that. And then with respect to charge as well, for Br minus to become neutral molecule, each ion needs to lose an electron to do that. An easy way to check as well whether these are balanced with charge is if you have a look at this side of the equation, I've got 4 pluses and 2 negatives, which gives me an overall charge of plus 2. And here I've got an overall charge of plus 2. For the hydrogen, this is neutral, and I've got 2 pluses and 2 negatives, which overall is neutral. Here I've got an overall charge of minus 2 because I've got 2 Br minus negative ions, and of course here I've got an overall charge of minus 2 because I've got 2 electrons. So normally we are actually given our half equations and we combine them to give a full equation. So let's have a look at how we do that. So here are my two half equations that I am going to need to combine. So I've got potassium becoming potassium plus an electron, and bromine with 2 electrons becoming 2 Br minus ions. Now, in order for me to combine these two, I have to make sure the number of electrons are the same, because whatever electrons are produced by the potassium equation will be used by the bromine here. So I've only got, at the moment, one electron being formed, but I require 2 electrons for bromine. So in order for that to balance, I need to times this potassium equation by 2. So let's do that. We times it by 2, and those are the two equations that I have. Now I've got those, I can add them together. And in order to add them together, it's quite straightforward. And if you've done simultaneous equations in maths, you'll be familiar with this. I add together everything on the left-hand side, and then that goes to everything on the right-hand side, which is going to be here. So if we do that, we will combine all those together. You'll hopefully see that I've combined everything in the blue over to the left hand side, and everything that's circled in black onto the right hand side. And now you can see hopefully that I can start cancelling the electrons, because I've got 2 electrons on this side, on the left hand side, and also 2 electrons on the right hand side. So if I do that, I will end up with an equation which now does not contain any electrons, which is good because we don't have electrons in our balanced symbol equations. But of course my 2K plus and 2Br minus ions can be combined to just give me 2KBr. And that's the equation that we would be more familiar with. So we're going to do some examples now, and these are the equations we are going to use. So I am going to combine, first of all, this equation and this equation, and then in my second example I'm going to combine these two equations. So let's do the first example. Okay, so the first example, I have put the reaction at the top there. So let's go back and let's think about what those equations are. So these are my two equations that I need to combine. So the first thing first we need to think about is, do I have the same number of electrons in both? And you'll see in the top example I've only got 1 electron being produced, but the second one needs 5 electrons for that to work. So I need to times that top equation by 5 to give me that equation. Now I can combine, so I can add together everything on the left hand side like so, with everything on, and that will go to everything on the right hand side. So let's do that, and I will end up with this well, rather complicated looking equation. I can of course cancel out my electrons, so let's do that. They can go, don't need those, to give me my final equation, which is on the page there. It's always good to do a quick check of charge, so let's add up the charge on the left hand side first of all. So I have got 5 times 3 is 15, plus 8 positives, and I've got a minus 1 there. So that gives me overall 22 positives. And on my right hand side, I've got 5 times 4 is 20 positives, plus 2 for Mn2 plus, and that again gives me 22. So it's the same, which is a relief. So final example, we are going to combine these two equations together. So let's just remind ourselves what they are. Now I have got the top equation produces 2 electrons, but the second equation requires 3. So of course they need to both have the same number of electrons, and so I need to times the top one by 3 and the bottom one by 2, and that means that both will have 6 electrons in them. Once I've done that, I can combine them. So again, I combine everything on the left hand side, which is this, with everything on the right hand side, and everything on the right hand side gets combined together to produce this rather difficult equation there. Again, I can cancel the electrons, but I can also cancel something else. So let's cancel the electrons. That's going to go. But you will have maybe noticed I've got 16H plus there and 6H plus there. So if I minus 6H plus from both sides, I can again simplify it a little bit more. So if I do that, that will give me my final equation, where you can see I've now only got 10H plus on the left hand side. So let's just finish off by doing a quick charge count on the left and the right hand side. So on the left hand side I've got 10 plus there and a -4 overall there. So that gives me a difference of +6 on the left hand side. And here I've got 2 times 3 plus there, and that's the only charge there, so I've got +6 there. So again, charges matches on both sides. So I hope you found that video useful. There's lots of videos available on my website, and also if you're interested in some tuition, we can arrange it online, or if you're in Sussex, we can have face-to-face tuition in Brighton and also in Worthing. So if you're interested, please go to my website and just send me a message.